There we go. Hello, everyone, and welcome to the Frequency Community Call for Thursday, 19th of December, 2024, the last community call of 2024. We've got a nice list of things in today's agenda, so let's get right into it with releases. Upcoming release, we've got a few little things coming in the next release. Passkey Proxy V2 is actually in an RC and already being tested on testnet. There's some handle tweaks which will probably get merged in here soon. One of the discussion items for today actually has come out of that conversation for that PR. And then for people tracking it, we've been working on eventually upgrading to Polkadot SDK, the new version just released a few days ago, v24.12. And so that is probably coming in one of the soon upcoming releases. The big advantage to 24.12 for frequency is that it includes a full update to the fork-aware transaction pool, which gave us some trouble a little bit ago. There are a couple nodes running with local nodes running with a version of that. This will upgrade all the rest of the nodes to it as well. So that's exciting to see. We've also, just today, live on mainnet is version 1.15.1, runtime 135. So that was exciting to see go out and nobody noticed, which is always a great thing with new releases when people don't notice that you swapped upgraded the version. So with that, we'll also, before we get into the community updates and the year in review, I want to note that we do have an update around if people have noticed some of the slowness on frequency over kind of the past week or last week or so over the weekend. That was not just frequency, that was all of the Polkadot parachains to various extent experience that. There's still a couple issues on the Polkadot relay chain that are trying to get cleaned up, but it has mostly resolved as far as timing goes. So that's good to see. Now, let me see one other thing here, and we will get started with the year in review. And do that. Let me reshare with audio sound because we have, there we go. We have, for anyone who watched some of the Project Liberty Summit, I wanted to share the video that was presented there. This is very much a kind of vision into a little bit of the future. So please enjoy this frequency look towards the new year video.
Imagine a singular online identity that belongs to you, one where you control how other companies interact with your data, where you own your connections and content across applications. Join us on the People's Internet and log in with Liberty. Use your universal handle to browse content and post videos.
All right, first day in Miami, and it looks pretty beautiful.
Add some text and post online. Now let's use our universal handle in another app. Using Login with Liberty, your content and friends will follow you on any platform using Frequency.
All right, first day in Miami, and it looks pretty beautiful.
Frequency offers you control, community, and ownership over your data with a username that cannot be copied or repurposed. A name that represents you. The People's Internet is here. This is Frequency.
There There we go. Just a quick little look into kind uh, of the future and where frequency and some of the applications built on top of frequency are going. Really exciting to see where things go. But we want to talk numbers for 2024. Here's some look at frequency development numbers. So this is the code being added and removed throughout the year. You can see just a lot of activity throughout the year. You can see not so much at the early beginning of the year. A lot of work was at the end of 2023 and then preparing. But you see a lot of just kind of steady work. And this actually kind of leads to lots of 158 issues closed, 199. Hopefully, we'll get over that by the end of the year. PRs merged. 11 people, 10 releases, lots of people working on. This is the frequency repository only, so this doesn't capture all of the community development numbers, right? So, there's provider dashboard, the website, style guide, documentation, sign in with frequency, gateway, and many more. Across all of these, not counting like partners and stuff, over 600 different pull requests. Now, obviously, pull requests could just be really small, but a lot of them are really big. And so that's just a kind of easy way to see that the community and the work ongoing around frequency is active and happy. You can see this in some of the numbers around the community. We've been checking in on each one of these frequency community calls, but 1.4 million MSAs on chain, thousands of Twitter followers, hundreds of Discord members, some of you showing up today. Thank you. 3 major partnerships just recently announced. If you haven't heard about those, partnership with Consensus and with SOAR and all of their different applications they're building. We are 8. So exciting to see some of these in 2025 actually join and start seeing even more chain activity coming out of these different partners. So really excited to see all of this activity in 2024 and moving on into 2025. I want to pause here real quick and see if anyone has any other notes to say about 2024 working on frequency or kind of highlights from the year. I know some of the big highlight features for me are some of the ones that just went live with 1.15.1, the release that just went live this morning with all of the code in place for provider boosting to happen. That was a lot of work over the last year. A lot of other great work. Cool. We will go on to we have a new series to start here in the community call, frequency architecture series. So this is part 1 of the frequency architecture series, and I really want to use this as a way to help people kind of grasp what the basic concepts are, how to think about the data structures and the interactions that happen on frequency so that it's really easy to kind of pick up and understand the documentation as a whole. So with user and identity on frequency, we really start off with just one little thing. A 64-bit identifier, this little tiny thing, a snowflake of uniqueness, and that is identity on frequency. Now, obviously, that's not everything about identity on frequency, but we usually refer to this as an MSA ID, but at the end of the day, it's this little tiny 64-bit identifier that sits on chain, and that is the permanent identifier for that identity inside of frequency. Now, some people might actually be asking, especially if you're used to working with identity in other blockchain environments, why not use a public key, which is a much more common source of uniqueness? And there's a couple reasons for that. One of them is just pure data storage. So a 64-bit identifier is much smaller than a lot of the other public keys you see on chains like in Ethereum are 160 bits. And while that doesn't sound like much, it's more than double the amount of size. And so when we start using this identifier all over the place, that size really starts to matter. However, it's also true that a 64-bit identifier isn't just the end of the identity, right? So we take a couple different things. So one of these is, how do you kind of manage this 64-bit identifier? How do we know who actually is the identity behind the identifier? And so for that, we have control keys. Those are keys that are attached to the 64-bit identifier, and they manage whether information about that identifier, they are the authorization that is held by a human or a computer that actually controls that identifier. We also attach other unique kind of special information to this. Handle is a good example of something that needs to be unique. It has a unique data structure. It matters, right? We can't have two 64-bit identifiers having the same handle to keep that handle unique. And so we have this kind of small set right now of control keys and handle that are very much unique and special for that 64-bit identifier. I'll also note here one of the other advantages of having control keys that are separate from this identifier is that those control keys can get changed. You can have multi-key setups. You can rotate keys. You can have cold wallets controlling things. Provides a lot more of that security while still maintaining that anchor of an identifier. So that's kind of this ball of uniqueness we have, but we can keep going a little bit farther. Right? There's a lot of other data that ends up attached to a user to an identity. We have things like social graph, public keys for encryption, token addresses, profile. These are all things that are user indexed, meaning if I usually want to look these things up given that I have a user. Sometimes, right, there's the case where it's like, oh, I'm searching for a profile and things, but usually I have that 64-bit identifier, and so I can look at what's connected to that 64-bit identifier, and I can say, oh, okay, there's the social graph, there's the public keys, there's the token address, there's the profile. Those are all connected to that 64-bit identifier, and primarily they're indexed on that user. Now, in frequency, these are often stored inside of the actual data for these is stored inside stateful storage. So that stateful storage kind of is where the social graph lives and public keys, token address, but some of it, such as profile, contains external content, user content that we don't want to be stored on chain for lots of different reasons, but size is an easy one of those. So that profile we actually take and it's actually just a pointer to decentralized storage, such as IPFS. It doesn't have to be, but usually when we have things that are referenced off-chain data that's referenced on-chain, right now that's all pointing to decentralized IPFS storage. So that gets a lot of things, and I bet a lot of people are thinking, oh, well, there you go. That's the sum of a user and their identity. But it doesn't end there. So we can take a look at other things we have. So users also have things like social posts, there's replies, there's content attributes. There's this whole kind of bundle of things that instead of being user indexed, tend to be time indexed, right? Whereas I look for a user and then I want their more or less singular kind of profile or their social graph. When I'm looking at social posts, I'm looking at many different users' social posts. If I'm looking for attributes and attestations, I'm kind of looking for larger bundles of things. So these things are time indexed, and they also can point to each other as well, right? So, right, if I have a social post, it's a replies to that content attributes. All of those things then also can point at the identifier. So we can, given a social post that was indexed on time, I can then look at that post and see, well, who who actually is this associated with, and imagine this, what's their profile, right? So you can start to see kind of this flow of like, oh, there's this data that we have that is mostly kind of centered, it's special, it has uniqueness around it. We have data that's user indexed, that's stored either on chain or referenced data off chain. And we have this time index data that is indexed by time first, and then itself references that 64-bit identifier. But again, like the profile, these things don't always end up just being data that's on chain. They also, of course, usually end up having additional external data that's sitting out there in IPFS. So we have this kind of bundle of how on frequency we start thinking about identity and uniqueness, how we think about data being attached to it. We have this time index and user index data. I mentioned user index data is often sitting inside of stateful storage, which is storing information on chain or references to off chain data that is indexed to the user. We also have message data that tends to be time, and that's the time index data, and that's those social posts and stuff. So we actually have different storage mechanisms for them, but they all follow into and kind of point in some way either from or back to those user 64-bit identifiers. So that's the kind of the big thing. Next time, we're going to be talking about applications in the architecture part 2 and start to see, okay, now that we have a user and how user data looks like inside of frequency and some examples of that, how the applications themselves kind of start interacting with users and that user data. So there we go. Hopefully, for those of you also listening here, we're going to try to also break out that little section as well and maybe post it elsewhere. But I'm going to throw it open for questions around all of users and identity on frequency and that architecture setup in case there are any. We can go a little deeper. There's obviously lots of different documentation and stuff on that, but hopefully that gives a nice little kind of view into how the data and information is structured. I'm not seeing any hands thrown up or questions in chat. That either means I was too confusing or it's all perfectly clear, one side or the other. Let's go back to our list here. So definitely, if you have any open questions, throw a hand up. But right now, we're going to flip over to our discussion items. So we have one major discussion item for today. So there's two things on the list, but we're going to focus in today on the custom RPC removal. So this is a question that kind of came out of our current pull request around handles. And it's a question of how should frequency handle and interact with the custom RPCs inside of the Substrate Polkadot SDK system. So this is going to get a bit technical, so feel free for those people who aren't as interested in this to drop off. I completely understand if you do. But people who are interested, please stay on and join in the details here. So custom RPCs, there's in Polkadot SDK Substrate, there's two different types of RPCs. Some of them are built into the runtime API. The nice thing about those is you can add to it an upgrade just with an upgrade to the WASM. So for example, just this morning, right, we upgraded to 115.1. And that, I think, added some one or two very small runtime APIs that people can use and interact with. And no nodes had to be upgraded. That's the critical piece here. No nodes had to be upgraded in order to support those new runtime APIs. So that's great. Runtime APIs have versions. If you correctly manage them, we don't have issues of kind of API changes. There are a couple original reasons for using custom APIs, and one is consistency. Even if the underlying APIs change, runtime versioning helps. The runtime APIs have evolved a lot since this early time, and can help with that. You still have to, obviously, versioning. You still have to upgrade your version, perhaps, but there is some help there. It also uses the kind of Rust binary instead of WASM for calculation. So if we have something that's heavy calculation-wise, that could happen inside of Rust instead of inside of the WASM. There's a few places we do some of that. The API responses, so one of the big advantages to custom RPCs is that you don't have to interact inside of the scale data, the scale encoding structure. So WASM pretty much only speaks the scale data structures. And so if you call the runtime API, you have to be able to do the encoding and decoding to and from scale data. However, when you have a custom RPC, you can interact in your kind of traditional RPC, JSON RPC kind of structure. You pass it JSON RPC, you get back JSON RPC with at least non-scale encoded data for the most part. The Gateway project helps a lot with this, but not completely. The other one is that there are some RPCs, and this is probably true that there's no way around this, but off-chain indexing, for example, is a custom RPC, has to maintain that status because it's not calling into the WASM. I don't think there's a way around that. So this kind of brings up the question, one of should we remove and deprecate most of the custom RPCs? Can we get rid of them? Do we want to stop adding new ones? I believe here's ones, yeah, that are node specific ones, and yeah, here's a good example from Joe on the if you calling with an RPC call, you can call it this way, and it gets back with a custom RPC, and it gets back this nice encoded value. Whereas with a runtime call, you have to do your scale encoding, and you get back a scale encoded value that you have to parse. So for me, this is probably one of the biggest impacts here between the runtime call and the custom RPC. But at this point, I'll throw it open to others for kind of comments. Which is it something we want to deprecate, limit, stop doing? How do we want to think about this more generally for the for frequency? Everybody's quiet today. Aramik, go ahead. There you go.
Hey, yeah, thank you. So what do you think about the ones that we cannot remove? I think those are, so the ones that we can remove, okay, let's say we remove them, but still we cannot be 100% custom RPC free in the end.
Yeah, I think that's all. There's a level of, I think in some ways we should perhaps call these, like they'll still be custom RPCs in the end, but we should think of them as node calls, node RPCs, as opposed to chain data RPCs. Because these are requesting information it may be derived from chain data, but it's held by the node, especially in the missing nonce values case, right? That value is only held by the node if it's in the future queue. So
oh, it's
the future
both
queue.
of them actually, because
Yeah,
the other one Off-chain database, yeah.
Right, it uses the off-chain database. So I think I think the maybe it's a better way to say, should we remove the trying to think of a should we remove the ones that are, we have some that are just pure pass-throughs, I think is a good example. And the pull request I just put together, where this kind of conversation comes out of, is an example of a pass-through one that let me see if I can find it here real quick in the RPC. Um, so yeah, so here's the RPC one, and you can see some of the conversations about this exact thing that came out of. But it's literally it's calling the runtime API at the best hash. It's mapping it effectively into the proper data structures, and then mapping that out to an RPC. There is, effectively nothing that this custom RPC is doing except scale decoding, scale encoding the base handle, and then scale decoding the value coming back from the custom API. So that's an example of somewhere we're doing that. And is that scale encoding and decoding enough to keep the custom RPCs around, I guess? Wes says the ones that are here, Wes, if you want to join the conversation, you can.
Yeah, I mean, I think there is. I don't think gateway is the right solution for some of these read-only things because it then requires you to know a provider that you can use the gateway of for things that are effectively just read-only operations directly against chain data. It's nice to have a clean API for those. If you, especially if you're like writing them in a single page web app or something, right? Um, a good example is maybe something like the metrics stuff frequency site that could use RPC conventions. But I think you could build a very simple shim layer that just runs at the client side and doesn't have to sit at the custom RPC layer. Maintaining that might be a different question, right?
Yeah, something that does an easy job of scale encoding and decoding.
Yeah, and just some exposes the useful pieces of the runtime API to be directly consumed that way.
Yeah, I know part of why it's so small is that the scale encoding encoding and decoding require types for every single thing that you wish to interact with. And those become static types effectively for those interactions. So you lose the ability to do like additive, adding additional data fields to an RPC that you can do inside of just a standard, JSON decoding, which allows you to do a bit more of a fuzzy data structure system. Ramik, your hand's still up. But I know whenever someone's sharing screen, that might not be. Yep. Anyone else have any comments on it? Nobody right now. Okay. I don't see any. I guess the shorter question is specifically for this PR is special. This PR specifically, in that it's the one that kind of the discussion came out of. It sounds like nobody's feeling super strong either way. there is the I think Shannon, you posted this note of some of the problems with this and the client trusting it. Yeah, go ahead, Shannon.
Yeah, I mean, given that you actually can call the runtime API with a state call, and given this here, that you're showing, I actually feel like we shouldn't implement new custom RPCs.
All right. Uh, Anyone else want to give an opinion one way or the other? Ramik, go ahead.
Do we have the impact on the other teams that are consuming these because we are not the consumer of those mostly?
Yeah, that's a good question. I don't know if anybody um, else here wants to kind of uh, pop in with a let me see if anyone wants to pop in with uh, a, a point there. I know the RPC in particular um, is one place that we can do it. In chat, there's a good comment of we could start with like see how many RPCs are actually used in Gateway, um, and perhaps at least tag those as deprecated and come up with a list of those. Let me add this to notes from all 2024 12 19. Um, could we start? Shannon. Oh,
Yeah, I mean, I wanted to make clear, like based on that guidance, they're not telling you to just go start ripping out all the old custom RPCs. They were advising mainly just don't implement new ones. And if obviously you could keep them around if people are depending on them. But it was, I think they made some good arguments against implementing new ones, especially with the new JSON RPC and API.
that's right. Does the new JSON RPC API solve some of the encoding issues with I don't I have not had much interaction with the brand new API. I saw that
Oh,
it was there, but I forgot about it from this perspective.
well, it's not set to go in for a while, but it does make it really hard to add new custom RPCs.
Hmm. Uh, yeah, some of the ones that people don't know if they're using. Um, uh, should not add, but also should not remove, but also not add new ones. Uh, One last piece of this puzzle uh, is the question of um, as frequency moves the toward the Ethereum ecosystem, and there's still a lot of unknowns about that and how exactly it's happening and such. But I wonder if there is a, a part of me that wonders, do we want to actually go the other direction and actually expand our custom RPCs uh, for to be able to then have both substrate specific stuff, right, but also non-substrate, more Ethereum centric calls that it doesn't matter which if you're calling kind of from the Ethereum ecosystem or from the Polkadot substrate ecosystem, you can kind of get all that data. So I think that's another question. I'm curious if there's any thoughts about. It's obviously projecting a bit into the future, but thoughts about how these kind of custom RPCs might interact with the uh, with that side of the equation into the future. Matthew, go ahead.
Yeah, on that point, I think as we move into a new ecosystem, it kind of points more towards abstracting out as much of the RPC into a shim layer, as Wes was talking about, or something like that, that gives us more lower level architectural options for whatever RPC mechanisms we need for substrate or Ethereum.
Cool. All right. With that, I'll ask kind of final to summarize. It sounds like there's general agreement that that new custom RPCs should be on a specific need only. Maybe is that a good way to state it? Leave the existing custom RPCs for now, and then maybe a move suggest gateway start to move away from using custom RPCs so that gate, where possible, so that the gateway is less dependent on node version as well. Does that sound like a pretty reasonable summary of the general agreement? Speak now, or your silence represents agreement in this case. All righty. We got a positive affirmation for it. There we go. All right. And I'm sure this will continue to be a conversation going forward as well. Let's go back to look at the agenda because I think we're at the end of today's setup. So yeah, we'll go through the other discussion items in January. So once again, flip through all those. Next time, 16th of January, 2025. It's going to be an exciting community call with lots of new things for the future. Have a great new year, everybody, and we'll see you next year.